Welcome back, everybody. In this section, we are going to talk about faults. So what is a fault? This is going to be any fracture in rock along which movement has occurred. Something like this or this. So if you have a fracture, a crack, but there is no movement, that is called something else. It's something called a joint. To be a fault, there has to be movement along the crack. So now we ask the question, where do faults happen? And the answer is going to be generally closer to the surface of the earth in the zone of brittle deformation. Like breakable, like bones can be brittle, means they break. Temperature is going to be cooler, closer to the surface. Pressure tends to be a lot to break rock. Rate of deformation needs to be fast because we're breaking it, not bending it slowly. And composition of the rock could be anything. So the first type of fault we'll talk about is a normal fault. We take some block, we pull it apart horizontally, tensional stress, and what we get is a normal fault. Now I'm going kind of quickly here because this is review. If you want more detail, you can go back to Unit 3, Section 2. Now, you imagine we're pulling apart an entire region, a whole area of the Earth, and you zoom out and look at the landscape. What does it look like? You'll see this alternating pattern of what are called horsts and grabens, German words here. So you have the horst kind of horsted up, grabens being sunk down, alternating across the landscape. Importantly, these are a series of normal faults. You look, each one is a normal fault, and this is very common in the Basin and Range province of the United States. Now, let's say you do the opposite. You take an area and you push it together under compressional stress, which you would have called a reverse fault. Finally, you imagine you take an area, a chunk of rock, you take one part and pull it towards you, you take another part and push it away, and the result is something called a strike-slip fault. It's going to be the result of shear stress. But the most important strike-slip fault that we're going to worry about is our starting point for understanding the whole western United States, and that's the San Andreas Fault. So we have shear, one part is moving this direction, the other part is moving this direction. And here we're going to ask the question, what is it going to look like in the future, right? As things continue to pull apart, this part of the United States will keep moving up relative to the rest. What is that going to look like? Well, what's going to happen is that part of the western United States, the part that is on the southwest side of the San Andreas Fault, is going to slowly move up, right? So, if you're trying to get rid of Los Angeles, I have good news. It's going to be gone in about 5 to 10 million years. Okay, well, maybe 10 million years is a little bit soon. Actually, in about 10 million years, the idea, based on plate tectonic motions, measurements of how fast the plates are moving here, it'll actually be just a little bit north of San Francisco, so it'll be NorCal for a while. However, over millions of years, continuously, it's going to keep moving up north until it becomes a part of Canada. So we will be rid of it for a while, but not forever. It'll keep moving up to the northwest until it touches Alaska, and then we'll have it back again. So with that out of the way, what happened in Arizona? Well, Arizona, at least the southern part, including the Phoenix area, is part of what is called the Basin and Range province. Now, to understand, we need to go back about 25 million years. You imagine, and we're not going to worry about why or how, that this part of the United States, western United States, is under a great deal of compression. The San Andreas Fault develops and relieves that compression, leading to extension. So we know now extension is going to lead to normal faulting, and it is this paired off normal faulting, the horst and graben, that leads to the topography of the Basin and Range province, this alternating system of valleys and mountain ranges. The next few slides in the PowerPoint are videos that I want you to watch. Be prepared, understand them. They go into more detail than I'm going to go into here. All right, with the review out of the way, next we're going to move into folds, right? So what has to happen to rock to make it look like this?